Hello guys, today we are going to discuss about photoelectric effect. I think all of you have heard this term photoelectric effect. All of you know Einstein in 1905 explained this photoelectric effect. Okay, so we shall discuss today about photoelectric effect. What is the meaning of this photoelectric effect or what happened according to this effect? And also Einstein was able to give explanation of different points of this photoelectric effect using Planck's quantum theory. Okay, so what are the points which was Einstein given? We shall discuss all these things in this video one by one. Okay, so let us start the video. Before that, if you are new on my channel, then please subscribe my channel and press the bell icon so that you will get notification when I shall upload my new video. Okay, so let us begin the video. Now see what is photoelectric effect. When an incident light of radiation with certain minimum frequency can be denoted by the symbol nu naught, strike the surface of a metal, then the electrons are ejected from the surface of the metal, and this phenomenon is called photoelectric effect. Means when an incident light with certain minimum frequency, means that incident line have this certain minimum frequency, when strike the surface of any metal, then the electrons present in that surface of the metal will be ejected from that surface of the metal, and that phenomenon will be called photoelectric effect. Okay, now you have to know what is minimum frequency. Minimum frequency is that required frequency, or you can say fixed frequency, for emitting the electron of the surface of the metal. Okay, means below that minimum frequency the electron will not be ejected from the surface of the metal. So this is the required frequency. Okay, minimum frequency means required frequency of the incident light for ejected the electron from the surface of the metal. Okay, so and this minimum frequency can be known also threshold frequency. Okay, means minimum frequency also known as threshold frequency. Okay, so this is fixed frequency for emitting the electron from the surface of the metal. Okay, below that frequency the electron will not be ejected from the surface of the metal. Okay, now let me draw one diagram. Suppose this is the metal and this one is the surface of the metal. Okay, this is the metal and this one is the surface of the metal. So according to the definition of photoelectric effect, when an incident line of radiation with certain minimum frequency strike the surface of the metal, means when an incident light, suppose this one is the incident light. Okay, this one is the incident light having this certain minimum frequency. Okay, so this one is the incident light. Incident light having minimum frequency, then only the electron will be ejected from the surface, na? Minimum frequency. Okay. Now the electrons present in this surface means here these are the electrons present thus in this surface of the metal. Okay. So now these electrons will be emitted or will be ejected from this surface when incident light will strike this surface. Okay. Now this electron will be emitted like this. Now this electron will come now here. Okay. So in this way, like this. These are the electrons. So this is the photoelectric effect. Okay. Means when an incident light having certain minimum frequency nu naught will strike the surface of any metal, then the electrons present the surface of that metal will be ejected, and this phenomenon is called photoelectric effect. Okay. So this phenomenon is called photoelectric effect. This is the metal and this one is the surface. Again one thing, the electrons which will be ejected from this surface, that electron will be called photoelectrons. Means this electron is ejected from that surface, then that electron will be called photoelectrons. Photoelectron. Okay. And these are the only electrons, and these electrons means after emitting from that surface, the electron will be called photoelectron. Okay. So this is the phenomenon of photoelectric effect. Now we shall discuss about the main points of the photoelectric effect which was given Einstein. Okay. Now come to the main points of photoelectric effect. Now see the main points of photoelectric effect. Number one is, if the frequency of the incident light is less than minimum frequency means threshold frequency, as I have already told, no electrons are ejected. That is, in this case photoelectric effect is not observed. Okay. Means as I have already told you, when the frequency of this incident light is less than this minimum frequency, means this fixed frequency, then the electron will not be ejected from this surface, and in this case the photoelectric effect will not be observed, means will not occur. Okay. This is the number one point. Now come to the number two. The velocity of the electron ejected depends upon the frequency of the incident radiation and is independent of its intensity. Okay. Means this electron, means this ejected electron, how fast these electrons will be ejected from this surface, this velocity depends upon the frequency of the incident light. Means if the frequency of incident light is greater, then the velocity of ejected electron will be greater, like this. Okay. But it is independent of intensity of this incident light. Okay. So the velocity of ejected electron do not depend upon the intensity of this incident light. It it only depends upon the frequency of this incident light. Okay, so this is the number 2 point. Now come to the number 3 point. The number of photoelectron ejected is proportional to the intensity of the incident light. Now the intensity of incident light is depend upon the number of photoelectrons ejected. Means when intensity of this incident light is greater, then the number of photoelectrons for emitting will be greater. Okay, because it is proportional to the intensity of incident light to number of photoelectrons ejected. Okay, so when the intensity of incident light is greater, then the number of photoelectrons ejected will be greater. Okay, so this is the number 3 point. Now come to the number 4 point. If the frequency of the incident light, now new we have let the frequency of incident light is nu is more than the threshold frequency, means minimum frequency, then excess energy h nu minus h nu naught is imparted to the electron as kinetic energy. Means if we apply a incident light of frequency greater than this minimum frequency, then the excess energy will be imparted to the electron as a kinetic energy. Okay, now see how we shall calculate kinetic energy. First, you see we have apply a incident light of frequency nu, this one, which is more than threshold frequency or minimum frequency. So first in this case, means for this incident light of frequency nu, the energy will be how much? All of you know, according to Planck's quantum theory, the energy is directly proportional to frequency. Okay, so for this incident light of frequency nu, the energy will be this one, and for this incident light of having this threshold frequency or minimum frequency nu naught, the energy will be directly proportional to nu naught. Okay, according to Planck's quantum theory. Now if we eliminate this proportional, then one constant will come, that is E equal to h nu, and here E equal to h nu naught, where h is equal to Planck's constant. Okay, so from this, what will be the excess energy? If we subtract this from this energy to this energy, then we shall get the excess energy, means from h nu minus h nu naught. We have, if we subtract this, then we shall get the excess energy. So this excess energy will be imparted to the electron as kinetic energy, and we know the kinetic energy is half mv square. this one half mv square, this will be equal to this excess energy. Okay, and this electron, this equation is called Einstein photoelectric equation. Okay, so this is the number 4 point. Okay, so we have discussed about the photoelectric effect and the main points of this photoelectric effect. Okay, so I think photoelectric effect is clear. So see you on my next video. Thank you for watching.